Hello and welcome to Academica's Aqua Circular Conference. We are sorry for the delay. We had some technical issues, but now we are here and we are live with Mr. Xavier Martinez Lladó, who is an environmental scientist, and he will make the next presentation. Thank you for accepting our invitation, and you may start the presentation now. We cannot hear you. You have a little microphone icon on the lower part of the presentation screen. You just have to tap the microphone button, please.
I cannot
Okay.
see the... Can you hear me now?
Yes, we hear you.
Okay.
We can hear you.
Sorry. So I was saying that I apologize for the delay. It was my fault, a misunderstanding with the time zones. But well, here I am, and I hope that you like my presentation and you find it interesting. So today I'm going to talk about building new value change in northern Spain in the water cycle. I mean, I'm gonna explain you several cases of a study that we've been developing in European projects focused on establishing circular economy schemes in industrial sector. So first of all, I'd like to give you some notes about the geographical zone area where these projects will had taken place. So we are talking about the Ebro River basin. The Ebro River is one of the most important in rivers in Spain. It has a length of nearly 1,000 kilometers, and it feeds water to a 2.7 million population, and its basin covers three countries: Spain, and a little bit a very small part of the basin is also in France and Andorra. And the thing is that this river, in the last decades, its flow, which currently it's around 4 cubic meters per second at the discharge, its flow has been decreasing progressively, mainly due to the economic development of the region and the appearance of new complexes and the increasing of population in the main urban regions of the basin. So furthermore, this river ends in a discharges in a delta, which is considered a very important nature reserve and a Spanish national park, which is currently facing several environmental threats. All of them, or most of them, related to the amount of water that the river transports. Firstly, the marine erosion. So as the basin contains a lot of reservoirs, so sediments are the transport of sediments is hampered by these reservoirs, so they are not reaching the delta, and then the erosion is progressively eating the land that forms this delta. The other thing is the saline intrusion. So as the flow decreases, the sea enters progressively the aquifer and the areas of the region. So the water at the delta is becoming more and more saline. There are a lot of water transfers from this basin to other basins, and that implies a decrease in a progressive decrease in the flow, and obviously the potential effects of the climate change, including not only water scarcity and droughts, but also potential floods that also can destroy or can remove even more land that from that delta, which is considered a very important um, reserve, a very important biodiversity region. So the first project had taken place in a chemical company located in Zaragoza. Zaragoza, you can see here in the map where that it's located in the middle of the in the midsection of the basin. And IQE, it's a company that produces precipitated silica, and for that uses a lot of well water, which has a very a not very good quality, as you can see, 4 millisiemens per centimeter. And so this water has to be treated using an osmotic system, a reverse osmosis system, so it can be used for the process, either from perform the precipitation reaction, but also to wash the final product and remove the impurities. So for the precipitation of this product of the silica, a lot of sodium hydroxide and sulfuric acid is used. So we end up with wastewaters with a high concentration of sulfate and sodium. These wastewaters are further treated in the premises of the company, and then discharged to the sewage network of Zaragoza and treated in the wastewater treatment, the municipal wastewater treatment plant, causing a lot of scaling and precipitation of sodium sulfate problems there. So the municipality is asking the company to improve their wastewater treatment, and they are pushing them to adopt new technologies. So we thought, and we proposed to the company, that we take advantage of this situation, considering that the wastewater only contains or mostly contains sodium sulfate. We can further concentrate this wastewater, thus recovering water and decreasing the total amount that the company abstracts from the wells. And this concentrate from the membrane, the nanofiltration system, try to evaporate it or further crystallize sodium sulfate that could be sold to other companies. So expanding the portfolio of products that the company has. So for the past 3 years, we've been studying that at pilot stage, and we've the conclusions are quite good. So we've reached a very good water quality, as you can see in the concentration stage permeate. We reach a 5 millisiemens quality of water. So this water can be recirculated to upstream to the reverse osmosis system, and so it can free water that it has been currently abstracted from the wells. And we've been also testing two technologies for the precipitation of the sodium sulfate. One is eutectic freeze crystallization, which takes advantages of the eutectic point, so we can recover quite pure ice, which can be further recovered as water, and a quite pure sodium sulfate solution, and also an advanced evaporation system. And so far, we've been able to recover sodium sulfate of a purity higher than 98%, which is quite good. So currently, that the company is considering is commissioning the installation of the first concentration stage that will be probably ready by the end of next year, and they are considering options for the recovery of sodium sulfate. And we've calculated that with this changes or with these implementations, the company would be able to reduce more than cubic hectometer of water per year, while generating profit from what since now has been considered a waste. Another case study is taking place in the lower part of the basin in the Tarragona area. This region is not hydrologically in the Ebro basin, but there's been a transfer of water from the Ebro River to this region has been in place for many decades. So effectively, it is also part of the basin, as 94 cubic hectometers per year are transferred from the lower part of the river into this region, where the water is used mostly for urban uses, including tourism. This is a very important touristic area, but also the water is used for industrial purposes, because here there's the most important petrochemical complex in southern Europe, which provides work to 41,000 people and produces the 25% of the chemical production in Spain. Water is transported by a 70-kilometer long pipe from the Ebro River into Aitasa facilities, which Aitasa is the local industrial water operator in the region. So the companies in the petrochemical industry have hired Aitasa to treat and distribute the water. Well, here are some facts related to the petrochemical company. I'm not going to go into detail, but the thing is that to alleviate the water pressure, the water scarcity in the region, the Catalan government has decided in 2012 the construction of a water reclamation plant that is fed by the wastewater treated in the Camp de Tarragona. The wastewater treated in two urban wastewater treatment plants. So this water reclamation plant treats this water and feeds that into the petrochemical complex. In a project funded by the former seventh framework program of research of the European Union, we've been studying together with a Dow Chemical company the viability of this water for cooling purposes in a petrochemical plant, mostly devoted to the cracking of ethylene. So the main concerns were corrosion, fouling, and variability of the effluent. So the results of the project were quite successful in terms that the operation was quite stable. That was a full-scale demonstration activity. So they were able to use or to replace 90% of water of conventional water, which remember is taken from the Ebro River, with reclaimed water, and that not only led to a decrease in the total freshwater abstraction, but as the water quality, the quality of the water provided by the reclamation plant was higher than the fresh water from the Ebro River, the company was able to increase the concentration cycles, so they further decreased the total abstraction, and also decreased the total wastewater discharge into their wastewater treatment plant. So that demonstration was the milestone for the other companies of the petrochemical complex start using this reclaimed water. And at the beginning, in 2012, the reclamation plant was feeding 1.2 cubic hectometers of water to the petrochemical complex, and currently all the production, all the reclaimed water is consumed by the petrochemical companies. So the next step, Dow Chemical wanted to go beyond the use of urban reclaimed wastewater, and they start thinking about reclaiming their own wastewater, which is quite complex, as you may see here. The composition, the quality of the wastewater from a petrochemical, from an ethylene cracker is quite complex. That it has, you can see that here, it has, it could contain recalcitrant compounds and quite high salinity. So we started a project funded by the Life Call, and together with Veolia and Dow Chemical, we developed a treatment train that we've been testing for the past 3 years in order to produce water for the cooling towers and also for the boilers. So we do not have yet the final results, but what we've seen is that the using an MBBR, a moving bed biofilm reactor, we were able to achieve high organic degradations percentages up to 90%, and no toxicity, no inhibition was seen into to the biomass that was used in this kind of reactors or biological reactors. Furthermore, we achieved a higher water quality in terms of total suspended solids, which is quite important for the treatment, for the membrane treatment steps that are in the last stage of the systems, of the recovery systems. We've been also testing new membrane developments that were able to achieve higher permeabilities, so less energy consumption was achieved, and we hope to have the final results by the end of this year. So beyond that, the petrochemical industry, the whole complex, is facing a project where they are constructing a centralized and integrated wastewater treatment plant for all the industries, for all the companies in the complex. That's because they need to adapt to the new European legislation and to the new BREF documents, which state that the water that they are discharging into the sea, the quality of the water will be improved. So this is something that they have already being commissioned, that they are commissioning. So we expect to have this complex integrated wastewater, industrial wastewater treatment plant by the end of 2022. But we thought, together with the local water operator and the companies, that it would be interesting to further reclaim water from the brines that are produced in the current water reclamation plant, and try to reclaim the water that will be the wastewater that will be discharged into the sea by the industrial wastewater treatment plant that will be constructed by 2022. So this will be done in a project that is started in the last months. That project is called Ultimate, and we'll try to couple nearly zero liquid discharge systems to further extract water from the brines produced in the existing water reclamation plant, coupled with innovative ammonia removal technologies based on zeolites, and also apply nearly zero liquid discharge technologies, advanced reverse osmosis and membrane distillation, to reclaim water from the industrial wastewater treatment plant that will be in place by the end of 2022. So that will be studied in a project called Ultimate, focused on the valorization of resources within the industrial water cycle. Not only water, but also the energy embedded in the water in the form of chemical energy, such as COD, or thermal energy, and also the materials that are embedded in and transported by industrial wastewater, saying nutrients, but also high added value exploitable compounds. So that's all from my side. Again, sorry for the delays. You can find more information at the website of Eurecat, at the website of the projects and the Twitter feeds. And also I'm at your disposal for any questions that you may have.
Thank you for your presentation. We are waiting for questions now from the attendees, because it seems that our next speaker also has some technical issues, so there is no rush. It looks like there aren't any questions so far. If not, then I think we can stop this webinar. Thank you again for your participation and for the presentation.
Thank you very much for allowing me to participate in this very interesting conference. And I'm at your disposal for any question that you may have. Please feel free to contact me at the address on the screen.
Thank you. Bye. Have a nice day.
Have a nice day. Goodbye.
Bye.